Welcome back to another engineering economics video. We're looking at an example that is going to show us how to calculate benefit cost ratio for a project. And we saw this screen image, the screen capture of the solution at the tail end of the last video, but I didn't really go through how these values are calculated. So let's do that now. Here I have an Excel spreadsheet that I've set up with the information that was given in the problem statement. We have this project that has a 5-year lifespan. We're going to have to invest in the project for 2 consecutive years, or at least we're going to have to start with some initial amount, and it's going to take us 1 full year. Once we get to the end of year 1, then the investment period will be over. The project will start running, and we'll start earning money. We'll start receiving benefits. But there will continue to be some annual ongoing costs throughout the life of the project as well. So what we need to do to be able to compare the benefits and the costs, we can't just simply add them all up because that would ignore interest. We need to include interest in all of our calculations because, for instance, we could have taken this $10 we invested here, or 10 million, or whatever it is, and we could have invested that in a different project that would have earned us benefits over time. And these other benefits over here that we're going to receive at some point in the future, those are future values, and so we have to discount them back to present day, because if we had that amount in our hands today, again, we could invest it, and over time that value would grow. So the point is, we need to find present values in order to make any kind of comparison between benefits and costs that has any kind of meaning. So we'll use our present value function, and the rate given in the problem statement was, I believe it was 10%. The number of periods, we're calculating everything back to what its present value is. So we need to look at how many years into the future do we either receive that benefit or pay that cost. So the n per value is just simply the number from the first column. There's no payment here, it's not repeating. It's just a one single time value of, in this column I'm calculating the present value of the benefits. In year 0 there is no benefit, the benefit is 0. I'm going to make that a negative B2. I know it doesn't really matter in this particular instance because it's 0, and the answer, the present value, is going to be 0. But when we get to these future benefits, I want to make sure that the Excel function doesn't flip the sign on me. These are still positive benefits, they're not costs. And we don't want the present value function to make us think that they're costs. They're still present, or they're still benefits. Okay, so here we can see that the present values of the benefits have been discounted. They're slightly less than what they are going to be in the future. So the way to interpret this is that if I had $16.53 and in year 0 at the beginning of this project, and I invested it for 2 years, at the end of that 2 years it would be worth $20, assuming that we have a 10% rate. So we have back calculated, in order to get $20 2 years into the future, what do we have to start off with? $16.53, and so on. So it makes sense. You should always be thinking about what these values are. Why do they make sense? It makes sense that these present values of the benefits would be less than what their values will be in the future. We are discounting them. I can write another function in here, but actually I can also take advantage of Excel's ability to copy and paste and shifting cell references over. If actually no, I shouldn't do that unless unless in this first formula I made right here, this cell reference to n, the value in the A2 cell, I should put a $sign in front of that. I don't want that to shift over when I copy it to the right. I know that didn't change my value here, but that's just a coincidence because the values in these two cells are both 0. But I need to make sure that my cell references for the present value function for the costs are the n value and the cost value, which now they are. I can take that and drag it down. Okay, so I can see my costs are all still negative, my benefits are all still positive, and again, the values have been discounted. The present values are somewhat less than their counterparts in the future. So now we can add them all up. We can sum all the benefits to find the net benefit, or the total benefit, and the total cost. So we have a total benefit of this project of $71.98 and a total present worth in terms of the cost of $37.41. So if I want to find my benefit cost ratio, that's just simply going to equal the present value, the net present value of all the benefits, divided by the net present value of all of the costs. And let's actually flip the sign of that. I don't want the fact that the costs are negative to confuse us here. And that shouldn't be a dollar amount. It should just be a number. 1.92. That's our benefit to cost ratio. We can see it's greater than 1. So that means there are more benefits than there are costs. And we can see that. There was almost $72 in benefits and about $37 in costs. So we can clearly see in this example that the benefits outweigh the costs. And of course we end up with a benefit cost ratio greater than 1. So that indicates this is a good project, even at a rate of 10%. If we work at a company and our minimum attractive rate of return is 10%, we want all of the projects we invest in to make at least 10%. We can see that is going to happen. That is going to be the case. This is a good project. So this value right here was just the total C, the total cost. Okay, but the problem also wanted us to break it down into I and C prime. I being the investment amount and C being the amount of ongoing annual expenses. So the investment period it concluded at the end of year 1. So these first 2 years we were spending, and we weren't receiving any benefits. We didn't start seeing the benefits of this project until year 2. So these first two values, these first two cells in this column, are equal to the investment amount. So it's that one plus that one. 1909 gives us our investment amount, and the net present value of the annual operating costs is going to be equal to the rest of the values. I'll just use a sum function here to sum these up. Okay, so that answers, I believe, all parts of the question. We found the net present benefit, the net present cost. We even took that cost and broke it down into the investment value and the annual operating expense. And we found the benefit cost ratio. It looks like I'm only about 9 minutes into this video, but this seems like a good stopping point to me. So I'm going to stop this video a little bit early, and we'll pick this chapter up starting in the next video.